Everybody, container with most water. Okay, most water, just like you want to negotiate the most money for your total compensation. All right, today it's going to be a medium question, so we're going to do it in 25 minutes. Let's get started. All right, so given a n non-negative integer a1, a2, with each represents a point at coordinate ia. N vertical lines are drawn such that the two endpoints of the line I is at ai and I0. Find the two lines which together with the x-axis forms a container such that the container contains the most water. Okay, so that you may not slant the container. Okay, so let's look at the example. We have height 1 to 7, which represents the height of these columns, and the output is 49. The above vertical lines are represented by array, and in this case the max area of water the container can contain is 49. So 7, 8, this is water, so it's the height of the water is determined by the shorter end of the heights. So this will have 7 times 8 is an index 1, 7 is an index 8. 7 minus 1 is 8. 1, 2, 3, 4, 5, 6, 7. Oh, 7 minus 1 is 7. 8. This is 8. Because 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 1 is 7. 7 times 7 is 49. Okay. And then example 2, height 1, 1. Output is 1 because if we have 1 here, 1 here, then we have 1 times 1. Okay. 4, 3, 1, 4, 3, 2, 1, 4. So if we look at these numbers, we will immediately know that the 4 and 4 are the largest, and in between they have 4 distance of 4 in between them, and thus we get 16. And then we have 1, 2, 1, which consists of 1 and 1 here. So 1, 1, and the distance between them is 2. So 1 times 2. So let's see the constraints. N is equal to height dot length. So n will be larger than 2 and less than 10 to the power. So it will be at least larger than 2, which means we don't need to consider scenarios where there'll be less than 2 heights. Okay. And the height is 0 to 10 to the power 4. Okay. It's not that bad. Now, I think because of the water consists of a container, I think we can start from the head and the tail of the array, calculate the max area, and then if one end is shorter, that means, so for example, one end is shorter, right? So if one end is shorter, then that means that this area is determined by the shorter end. So if this end is shorter, then we want to find a longer stick, right? We want to find a longer stick so that in the next area, in the next container, the area might be determined by a longer stick, right? Because one thing we know for sure is that the bottom of the container is shrinking every single time. So the bottom container is becoming shorter and shorter. So what we need to do, we need to do is we need to maximize the possibility that we will get a longer stick, right? So if the stick is shorter, obviously we want to get the longer. Hopefully we'll get a longer, but this time it's a shorter end, right? It's a shorter end. So we move up to here, and so the area becomes smaller, and then we want to move up again, right? So now we have a bigger end. We have a larger end, a larger stick, which makes up a bigger area, at least bigger area in this one. So this one, the 1, 2, 3, 4, 5 times 8, 40, and this one only has 3, right? 1, 2, 3, 4, 5, 6, 18, right? So this part is 18. This one is 40. So which means that at least our algorithm works partially for this in this case, because by shrinking the smaller stick, the shorter stick, we are able to retrieve a bigger area. So okay, let's see. Okay, so we definitely need. Wait, why is this? Why? Okay, so we definitely need a. So what do we need? We need a head and tail that iterate throughout. Iterate throughout the array and meet in the middle. And to calculate each area, we need to keep track of the maximum area. We need the variable. So I think that's pretty much it. Okay. So let's first of all let max water is equal to min. I think it's in.min. So because we want to get the minimum number so that we can compare it. Or actually, we can do -1 because the water is not going to be negative, right? So it's at least smaller than that, but it makes no difference because the in all consists of 4 bytes. Or 8 bytes, depends on your computer. Anyway, so we have -1 and the head is gonna be 0 and var tail is going to be height dot count -1. Okay. Okay, so they're gonna start from each end, both ends of the array, and while head is, so we want them to stay as we want the head to stay shorter than the tail, and if they meet, then there's no need to do the calculation, right? So while head is less than tail, so I'm thinking since there is since it will be larger than 2, so we don't need to think of a scenario where area is 0. So this is fine. And while head is less than tail, then we will get the left height is equal to height head, and right height is equal to height tail, and bottom is equal to head minus tail minus head. And then the area is going to be, so we're going to calculate the area, right? Local area or local water. It's going to be bottom times so bottom times whichever height is shorter. So it's gonna be times min left height and right height. Okay. All right, so next we're going to compare it to the global max water. So max water will be equal to max local water and max water. And then now we have compared the local water to max water. What we need to do is advance our pointers. Now, one of the pointers. So if left height is less than right height, then what we needed to do is move up head, and else tail minus 1. Okay. Return max water. Okay. So that's pretty much it. We have 13 minutes. We have 13 minutes. So I guess we have time to go through this, to eyeball this. So one, we let's take this example. Well, let's take this as example because this one is shorter. So head and tail will be 1 and 1, 2, 3, 4. Head and tail will be 1 and 4, 0 and 4, 4, 4, and 4. Bottom is 4. So max water, it's gonna be 16, and left height will be move up, and this max, the local area becomes 1, 2, 3, 9. Move up, the area is gonna be smaller, and then we'll return max water. Okay. So looks pretty good with the simple example. Let's see, run code if it's good. 49. Okay. All right. So let's see if we can pass. Oh wow. But only faster than 6.29 of Swift online submission. So I wonder what went wrong. Interesting. So can we make this better? So I feel like why is it so slow? Now it's 13.48. So it's kind of random. It's because of this left height. Oh, now it's 89.66. So it's all because of these variable assignments. Interesting. Okay. It does increase. I mean, having a separate variable does increase some readability, but I guess we also sacrifice performance. So left height. Let's get rid of one more. Oh, now it got back to normal. Okay. So now it's 80. Okay, right. This is too random, okay? This is too random. I'll just get back to change it back. Tail minus head. I think this is the best, as best as I can get. Already, anyways. So, alright, so this time is we're using greedy algorithm. So since we know that the bottom is shrinking, then we just always want the next determined height to be larger. And this is also a two-pointer question. So whenever we are looking for the maximum of something, we approach from both ends. Okay, I hope you learned something from this video. If you have a better solution, feel free to comment below, and I'll see you next time. Bye bye.